Hello class and welcome to Historical Geology, and I want to look a little bit at this lab on geologic maps. And this first map I have several problems with. It's not drawn correctly, and one of the problems first of all is when you have a geologic map and you're doing a stratigraphic column, you always have the oldest rocks on the bottom. We learned that in our little geologic time diagrams where we go from oldest on the bottom to youngest on the top. So essentially this stratigraphy is upside down, and so I've redrawn it here on the side showing the older systems at the bottom, younger at the top. Remember, these are abbreviations for the different geologic systems. This is for Cambrian, D is Devonian, then there's Carboniferous, Permian, Triassic, Jurassic, and Tertiary. But let's look at this map. And one of the first questions they're asking us here is to determine whether or not what the contact is between this Ridpath sandstone and the Cavalier shale. So the contact between the Ridpath sandstone and this Devonian Cavalier shale, this is going to be some sort of depositional contact. So for this one down here, you want to add, later on we'll talk about that it is, in fact it is an unconformity, we'll say this here. So it's going to be really a disconformity, only because I know that this Cavalier formation is Devonian and the Ridpath is Cambrian, so there's a whole Ordovician and Silurian that's missing right here. It is asking us about this gem fault, and it's telling us the gem fault is dipping 45 degrees to the southeast, and it wants us to explain what type of fault this is. So if we look at the map here, so here's a gem fault, and it's dipping, here we can put an arrow here showing that it's a 45 degree dip on that fault. And for starters, what I see right away, I see these older rocks. Remember, this is Cambrian, the blue is Devonian, and the yellow here is that Irving Carboniferous limestone. And we see that these overlie younger rock. So the only way to get older rock on top of younger rock is this has to be a reverse fault. And the way we draw reverse faults, the symbol we use are these little teeth. And the teeth point in the direction of dip in this case, right? So because it's telling us it's dipping toward the southeast, then the dip must be back in that direction. So this block here would be the hanging wall block, and it's pushed over the top. Over here would be the footwall. So we're taking older rock and placing it on top of younger rock. Older rock on top of younger rock. So hanging wall block, footwall. So we want to say this is a reverse fault. So the answer to the question up here would be we have a reverse fault. We want to say something to the effect that it's older strata over younger strata. All right, so the next one they're asking us about this store fault, and the store fault is vertical, dipping 90 degrees. So what type of fault is this? And explain our reasoning. And I was kind of puzzled as this one. And so here the store fault clearly is, since it's 90 degrees, it's going to be some sort of strike slip fault. And so in other words, one side of the fault is moving this way, the other side is moving this way, right? So, and it's clear that it's offset this younger tertiary basalt, right? So we see an offset. In fact, more specifically, this would be a left lateral strike slip. So when we answer the question up here, we want to say it's a left lateral strike slip because it's moving or slipping in that strike direction. Remember, strike is that compass horizontal direction, right? And so in this case, if I could measure this, ideally on a geologic map, you would need some sort of protractor to measure the angle. And remember that north is always at the top on these maps and south is the bottom. So the edges of the maps really represent a north-south line. So I want to measure the strike of this line. It's going to be some degrees to the west of north. So when I put my bullseye right at that angle there, I see it's trending up here at 15 degrees. So I got 0, 5, 10, 15 degrees. So the strike of this line is striking in the northwest direction. So it's going to be north 15 degrees west. So that would be the strike of that fault. And usually they would ask that question, but I don't know why they're not asking it on this geologic map. So we want to say that the strike for the fault is north 15 degrees west. So now we know that orientation. These next couple of questions get a little tricky, and it's a little upsetting in that there's some problems with the map. And they want to know the relative ages of the Store Fault and the Gem Fault. We want to use the ages of the surrounding rock. For the Gem Fault, I don't have too much of a problem with that one. So here I have these older strata that are on top of this Jurassic. So I have Cambrian, Devonian, Carboniferous rocks here, all on top of a Jurassic. And the Jurassic rocks are in contact with that fault. So it's a fault contact right here, which means that this fault must have occurred sometime after the Jurassic, right? So we want to say that the Gem Fault is younger than Jurassic. We don't know exactly how much younger because we can't really see relationships for other rocks, but we know it's something younger than Jurassic. So that would be our answer there. But for the Store Fault, here it gets a little tricky. It's obvious that the Store Fault has offset the young tertiary basalt. So we know that it's young. Maybe even, remember I said tertiary is Paleogene and Neogene. Well, if it offsets these rocks, then the Store Fault is probably Quaternary, which is younger than the Neogene and Paleogene, right? But the problem is all these other rocks are older. So these rocks should also, these older strata, all these other ones should also be offset, right? There should be some offset going on here as well in the same direction that we're seeing. So anyways, this map was drawn incorrectly, is what I'm saying. So all we can say for the Store Fault, based on the basalt, is it's younger than tertiary. In fact, I could tell this is an old map because we don't even use that word tertiary anymore. And so remember, the tertiary is an older Paleogene and a younger Neogene. So today that's where we break out the tertiary, we break them into two periods. And so the Store Fault is probably Quaternary, which we'd probably make it an active fault, right? All right, so that's a little bit. Now we want to describe the geologic units and all the kind of history, the erosion. So when they're talking about erosion, they're looking at unconformities and maybe even tectonic events. Well, that'd be the faulting. And so ideally we would want a column, sort of like we already have right here. So we can actually base it off this column. And so obviously the oldest unit here would be the deposition of the Ridpath sandstone. But then I see that between Cambrian and Devonian, I'm missing the Silurian and the Ordovician. So right here, I'm going to put a little wiggly line here. So let's make this number 1. That's the oldest event, the Cambrian Ridpath. And then number 2 would be the second event. And so for number 2, let's add over here that this is a disconformity. And I'm calling it a disconformity because I see parallel deposition between the Cambrian over here and the Devonian Cavalier here. Then we have Devonian Carboniferous, which is in line. But now after the Carboniferous, there is a Permian, so that makes sense. Then from Permian we have the Triassic, right? And that makes sense. Then we have the Jurassic. Now here between Triassic and Tertiary, we're missing the Cretaceous, right? So this is going to be another unconformity here. But this unconformity coincides with this faulting, right? So, okay, let's put the numbers back here. So this would be our 3. This is our unit 4 for the Irving limestone. 5, 6, 7. So pretty much what I'm doing here is the principle of superposition, right? Then I get some erosion event. In this case, I can't really see the contact here. So it's probably I'm just going to call this an unconformity. So let's make number 8 here an unconformity. I can't tell if it's a angular unconformity because I don't see these strata folded. So it's probably an erosion disconformity, just like this one over here. But I can't really tell that on this map, so I'm just going to call it an unconformity. That's kind of the generic term for that. But before I have the faulting, I want to show, before I have the basalt, I want to show that in here, In fact, maybe I was premature to make this number 8. Let's make this number 9. And number 8 will fit right in here. And number 8 is going to be this gem fault, right? So we got to put the gem fault in here. Remember, I'm erasing all this. So this is a gem fault in here. All right, so that would be number 8. Then number 9 would be this unconformity. Then we have 10, which is the basalt, right? The Duncan basalt. And then finally, the last thing would be the number 11 would be our store fault, right? And that's what you want to show. That would be the general stratigraphy of the events, right? 1 through 11. So we have 11 events going on here. So anyways, that answers that question for describing all the events that occurred here for number 5.